As the title of this video suggests, there is a relationship between perimeter and area of similar figures. I've mentioned it before when we were studying similar figures, but in case you've forgotten, here is that principle again. Here we've got two squares. To find the perimeter, we'll just add 3 plus 3 plus 3 plus 3 and 5 plus 5 plus 5 plus 5. So that gives us a perimeter of 12 and of 20. And the ratio of their lengths was 3 to 5, and now their perimeters are a 12 to 20 ratio, which does reduce, divide by 4, 3 to 5. Did you notice that the ratio of the lengths and the ratio of the perimeter are the same ratio? So if you have a scale factor of k, then the ratio of the perimeters follows that scale factor too. Now let's check the area. We've got 3 times 3 and 5 times 5. So an area of 9 and 25. The ratio of our areas is 9 to 25, which doesn't reduce. But do you see a relationship? What's the relationship between the same scale factor and the scale factor for the areas? Well, you might have noticed that 3/5 squared, 3 squared, 5 squared, is the ratio of the area. Do you suppose that only works on squares? Let's try some triangles. These are similar triangles, they're actually isosceles, I can tell by those base angles. So this first one will be 5 plus 5 plus 6 for perimeter, 15 plus 15 plus 18 for perimeter. So perimeter on the little guy of 16, perimeter on the big guy is 48. So the ratio of our lengths, we could say 5 to 15 or 6 to 18. Either way, that reduces 1 to 3, doesn't it? And how about the ratio of 16 to 48? Would that reduce too? 16 over 48 actually reduces to 1/3. Maybe you weren't surprised. The ratio of the lengths of those triangles is the same as the ratio of the perimeters of those triangles. Now let's check that area. This time we're thinking 1/2 base times height, 1/2 base times height. And we get an area of 12 and an area of 108. So that ratio, 12 over 108, what does that reduce to? Actually reduces to 1/9. So remember on the squares, we took the 3 and the 5 and squared. And on this one, it actually works just the same. We could take the 1 squared and the 3 squared, and we get 1 over 9. And so we say the ratio of the areas is just the square of the ratio of the lengths. That'll be useful for solving problems, like this gazebo one. Tells me that the area of this big gazebo is 309 square feet, and each side length is 8 feet. And then there's this tiny scale model, and it says for the scale model the perimeter is 24 inches. The perimeter, all 8 sides added up is 24. Would that make each side 3, right? 3 plus 3, 8 times would be 24. So each side is 3 inches. So we're talking a scale factor of 8 feet to 3 inches when we look at the real thing versus the tiny scale model. Can we use that to find the area of the tiny scale model? Well, we know the ratio of the lengths is 8 feet to 3 inches, and we could switch that over all to inches or all to feet. But we're going to be using a proportion, so we actually don't even need to do that. If the ratio of the length is 8 feet to 3 inches, then the ratio of the area, what would that be? Area square area. It's going to be the square of the length ratio. So it's going to be 64 feet to 9 inches. So we can say that 64 is to 9, as 309 is to that area that we're looking for. And again, we don't need to do any conversions because my top is in square feet. I didn't say that before. These are squared. And my bottom is in square inches. The 309 was in square feet, so my answer will just come out in square inches. I'll do some cross multiplying. I've got 64a equals 9 times 309. Divide by 64. And that little guy's going to have an area of 43.45, and that was in square inches, remember. So we didn't even need a formula for finding the area of an octagon because we were able to use this principle about similar figures. Anytime you build a scale model, they're going to be similar. Stay tuned for later in the chapter for an area formula to find the area of a regular octagon. One more example, installing carpet. And when we're talking about carpet, is that more of a perimeter or more of an area thing? Since carpet covers the whole floor, that's an area thing. You could think about carpet squares. We're talking about square feet. Let's start with our length scale factor. It does say that these rooms are similar. So we've got a length scale factor of 10 to 14, or if you want to, we could call that 5 to 7. That might be better. 5 to 7 is for the length. And we're talking about carpet, which is area. And so let's look at what the area scale factor would be. 5 squared, 7 squared. And now those are in square feet. And we don't have to do anything too fancy just because this is talking about money rather than square feet. Same principle, it's a direct relationship. So we're just going to make a simple proportion. So that our area ratio is 25 to 49. And we know the cost for the smaller bedroom is $225. And we're finding the total cost for that larger den. Cross multiply and we'll have our answer. And remember, since that $225 was in dollars, we just found the dollar amount for the carpet, $441. So a quick review, the ratio of the lengths will be equal to the ratio of the perimeters. But if you wanted to compare area, you have to square that ratio. And then a simple proportion will help you find the unknown perimeter or area.